Okay, so I'm just going to go through how to generate the live tooling. This is a pretty simple part, a cylinder, and I just want to put this little, cut this little CP logo into the end of it. And again, I just sketched a path. So when we go to do the cut, I'd have to set the Z value, something other than Z equal to whatever the edge here is. I just maybe set it 0.02 maybe into the part so I can actually cut this. So I'd start, if I were going to start from scratch here with a new manufacturing file, I would select an operation. We'd have to, of course, first pick a machine. So for us, I can pick the work pieces or the work machine tool templates. There is an SL20 live tooling template. Our machine used to be SL20 and now it's ST10, but they're pretty much similar, so I'll go ahead and take that one with the live tooling. Set a coordinate system, and I'm not going to bring a fixture in. We could bring in the 3-jaw chuck or the flipped 3-jaw chuck, but I'll go ahead and just skip that step and put a clearance plane in the, oops, how about the Z direction, 1.0. Bring in our part. So that is, let's see, this part. And hopefully I put already a coordinate system to match where I want it to be for the live tooling, and I'll put that here right on the end. So that for our live tooling, we've got, again, the Z pointing along the axis. This is a lathe now. So the Z's got to point along the axis of the rotating chuck. And then the X and Y are straight ahead and Y is up and down. Of course, Y, there is no Y axis on the lathe, at least on our lathe. The tool just moves in X and Z. And then for this live tooling, we can spin it in C. So really you have 3 axes, X, Z, and C. So for that, we'll just create, let's see, we can have an option here between milling operation or turning operation. And since we're going to use a live tooling, that's essentially a milling operation. So turning would be just the same way you did the handle part on the picture frame. But for milling, this only comes up now that we've got a live tooling machine. I can do just a trajectory cut. I can select a machine or a cutter, maybe just a 1/8 inch diameter cutter. Set some parameters. And then I have to select my tool motion, the curve cut. In this case, I'm going to follow along. Well, let's just do the C on this one. So there's a cutter, and it looks like the workpiece is staying still and the cutter is moving around. But as we know, this cutter is only going to move in the X direction. It's going to move in X while the workpiece rotates in the C direction. So it somehow has to coordinate the tool moving in and out in X and the workpiece moving back and forth or rotating back and forth in C. But that's it. I've generated the path. I can switch to my post-processor. And in this case, we're going to want, let's see, if we browse to our different post-processors, we'll have to pick the right one with the live tooling when it comes up. Oh, that's right. Our lathe only goes to 4,000. Actually, the new one goes to 6,000, so I put in a little bit too high. But the live tooling actually only goes to 2,000 RPM. So it's a little bit less robust than actual milling on the vertical mill. So the live tooling goes to a max of 2,000. So that's really where I'd have to stay for my this live end mill that comes in. So go ahead and generate the code. And here that comes the post processors. On the right here, Haas ST10 lathe with live tooling, this third one. And we can go check that out. We can open the CL data file. Here's the CL data file, and it's really nothing special on it. It doesn't really need a multi-ax setting because each go-to point has got an X, Y, and a Z. In fact, all the Z's are 0 because that sketch I made was just in the Z equals 0 plane. It could have a Z component, but it was just essentially a flat sketch I was making. But it has X and Y components for each go-to point. You know that the lathe does not have a Y-axis, so it can't really move in Y. So it's pretty much got all the information it needs in terms of just the X and Y movement here. And since the coordinate origin for X and Y 0, 0 is right on the axis, we can figure out the angle for C, the angle it rotates to, just by using the X and Y here, the inverse tangent of the Y over the X. So it doesn't give you a C, it just gives an X, Y, Z, but if we open up now the cat file, it does. It's got a corresponding, instead of X and Y, it's got an X and C for each step here. There's a few notes. You do have to know what you're doing in this live tooling setup. It says to add a G51 for any tool change. If I'm going to change to different tools, before I do that, I would put this G51 command. That makes sure that that whole tool carousel retracts all the way to the back, because we don't want to be changing tools anywhere near where the part is. We put in basically whatever tool we want, like a T101, that still works for the lathe. Then it says add M133 P2000. That's what the spindle is for the live tooling. In here we've got S4000 M3, but we're actually not even going to turn the main spindle on. We're going to leave that as is. We'll put in an M133. That'll engage and turn on the live tooling spindle. And then we actually want to put this M154 in there too. That enables the C axis. It doesn't want to move the C until we enable it. But once we get that in, the rest should be good to go, as long as that T1 tool 1 matches where we want to the tool we're trying to use. So I have a quick little YouTube clip here that's showing the live tooling, and as you watch, the tool, the end mill here, initially is stopped, and the main spindle is stopped, but the Haas live tooling spindle will engage in the back here. There's a little gear connection, and it gets this end mill spinning. And then it'll come in and out and cut some holes or some features while the main spindle moves back and forth in with the C axis on. Alright, so the end mill stopped. And it just turned it on. That was the Max 2000 for this spindle over here. And again, it's just going in and creating these maybe counterbore features while the C axis rotates about. And of course our CP logo is a little more interesting, a little more involved than just this indexing command. In fact, that's good.